All right, welcome to our day 1 of Simplifying Radicals video lesson. We have, starting off, just a refresher on how to simplify our radicals. So we're going to go over a few steps that you can use. Remember, you can always come up with your own, but these are options you can use. And then I'll show you how I go through and work them out when we do the problems. So steps for simplifying your square root expressions. Step 1. You want to factor the number under the radical. Okay, to clarify, this is called your radicand. What might be helpful for some of you is if you look for your factors that are going to be perfect squares. I will tell you, I don't normally use that, but for some of you, you're more than welcome to if that works for you. Step 2, we are going to square root the perfect square factor and bring it outside of the radical. You're going to leave the other factors inside. Okay, and step 3, you'll repeat step 1. If the number inside the radical cannot produce a perfect square when factored, then you are done. If you find another perfect square, then repeat step 2. Okay, so let's look at our practice problems down below. We've got completely simplify each radical expression. Okay, so starting off, I'm going to look at that square root of 50 and I'm going to factor it. So I have some factors for 50, could be 25 and 2. And then I will usually cross them off once I factored it. And so then that 25 can be factored into 5 times 5. Okay, so now we are left with our factors, and we have a pair of 2's here that will help us, so I'm going to highlight them. And so we'll end up pulling those outside of my radical, and then we have this 2 left over. Okay, so this is why I like to cross off the numbers once I factor them, is because it helps me realize what number is actually truly left over and which ones I've used. So once I do this, I'm going to pull out the 5, my pair, and I need to multiply it by that 4 that's already outside, and then we'll have that 2 left underneath. Okay, so now we just need to simplify. We'll have 5 times 4, which will give you 20, square root of 2. And there you have it. Our answer for number 1 is 20 root 2. All right, moving on to number 2. Okay, so with problems like number 2, you can sit here and you can multiply that 8 times 48 and then turn around and factor it. Or, as I like to do in class, I'm going to rewrite this with them both under the same radical. And I'm going to just factor them separately, but since they're under the same radical being multiplied, I can still use numbers from each one of them as a pair. Okay, so when I'm trying to come up with my pairs, I can pull one factor and match it up with a factor from the other one. And you'll see what I mean by that in here in a second. Okay, so we're going to take that 8 and we can factor that into 2 times 4. And then for me over here, I'm going to go ahead and factor that 48 into 4 times 12. Okay, and so this one stuck out to me because that's going to give me a pair of 4's. But then I'm going to go back to simplifying. Okay, so we have that 12 can be factored into 4 times 3. I don't have another pair to kind of group that up with, so I'm going to keep factoring. And then I have that 2 and 2 from that 4. Now that does give me another pair that I can pull out. And I'm going to have a leftover. We'll have that 3 and 2 underneath the radical. Okay, so I'm going to pull out my 4 and my 2. And then I'm going to have underneath that 3 and 2 being multiplied back together. All right, so now let's just go ahead and simplify. So we have that 4 times 2 will give me 8. And then that 2 times 3 will give me 6. So my final answer for number 2 is going to be 8 square root of 6. All right, now let's move into number 3. Okay, in number 3 here, we are asked to square the 3 root 5. And so just a reminder, when you square something, you are going to just multiply it by itself. So we have that 3 root 5 times 3 root 5. Okay, we've done this a lot semester 1, but I will say for some of you that might be helpful to write it out like this, because you'll see here that you are going to multiply your outsides together. So 3 times 3, and then you'll have that root 5 times root 5. Okay, so here when we multiply, we're going to get 3 times 3. And then that root 5 times root 5 just gives me a whole 5. So we're going to multiply by 5. Well, 3 times 3 gives me 9 times 5 will give me 45. So my answer for number 3 is just 45. Then moving on to the last one for this section. Okay, we have that square root of 12 times the square root of 3. This is going to be very similar to number 2. And so I'm going to do the same idea. I'm going to just put them under the same radical. And I'm going to write it out as me multiplying, but then I'm going to factor. So here for 12, we can factor that into 4 times 3. Well, that's going to give me a pair. Then we can factor that 4 into 2 times 2. And now I have another pair. So in this problem here, I don't have any leftovers. So that means I shouldn't have a radical in my answer. But when I pull out the 3 and the 2, make sure we are multiplying 3 times 2 from my pairs, and we will get 6. All right, now let's move on to rationalizing the denominator. All right, so we have steps for rationalizing the denominator. We've got step 1 is to multiply the numerator and denominator by the radical value. Okay, so I'm going to highlight that. Those are key things. We've got multiplying the numerator and denominator by the radical value. And to clarify, that radical value they're referring to is the one coming from the denominator. Then we move into step 2, which is telling us to combine like terms by multiplying the radicals. In step 3, you are told to simplify the radical in the numerator. Because if you are doing this correctly, then you shouldn't have a radical in the denominator. So simplify the one in the numerator if you can. Might happen you can't, but a lot of times you should be able to do something. All right, and then moving into our final step, step 4, simplify the fraction by reducing the like terms outside of the radical in the numerator and denominator. All right, so let's look at these problems here and just work through them. So we've got multiply the numerator and denominator by the radical. To clarify, you can take a few different steps here. For me personally, I like to simplify that radical in the denominator before I multiply by it. So I'm going to do a little bit of scratch work down below. I'm going to take that square root of 140 and I'm just going to simplify. So this is my scratch work. So I can factor that into 14 and 10. And then I can factor that 14 into 2 times 7. And my 10 can be factored into 2 times 5. Once I've done that, I'll notice here that I do have a pair of 2s that I can pull out. And then we're going to be left over with that 7 and 5. Okay, so we'll pull out our 2. We're then going to have to multiply that 7 and 5 back together to get 2 square root of 35. All right, so I'm going to rewrite what we have here with that 7 square root of 12 over that 2 square root of 35. All right, so when you are rationalizing, okay, a key thing that we look for in your work is going to be you multiplying that radical in the denominator to the numerator and denominator, like so. Okay, once you do that, then you can multiply. So we've got that 7 is an outside number, and then we're going to multiply the inside numbers together, so that 12 times 35. Then in my denominator here, I have that 2 times the root 35 times root 35 should just become 35. So I'm going to go ahead and bring this back down, that numerator back down here, and I'm going to simplify that 12 times 35. All right, so some factors of 12 are 3 and 4. We have that 4 can be factored into 2 times 2. That's going to give me a pair. And then I can factor that 35 into 5 times 7. Well, we have one pair, and then we're going to have that 7, 5, and 3 left over. So we're going to keep that 7, and we're going to pull out that 2 and multiply them together. And then we have that 3 times 5 times 7 left underneath the radical. Okay, so 7 times 2 will give me 14. And then we'll have that square root of, so 3 times 5 gives me 15. Times that 7 will give me 105. All right, so now going back up to the top, I'm going to rewrite it as that 14 square root 105 over, and then that 2 times 35 will give me 70. Okay, so we already know that step 3 of me simplifying my radical has already been taken care of, because if we look at what we multiplied to get that 105, we have all prime numbers and no pairs. So then moving into step 4, I want to look at that 14 over 70. And so here I'll notice that, that 14 is going to go into into the 70 5 times. And so therefore I can reduce this into, we've got 1/5. So my final answer here is that square root of 105 divided by 5. All right, so moving into question number 6 here, we have that 5 square root of 260 divided by the square root of 65. Okay, so going ahead, we can try and simplify, but if the factors for that 65 here are going to be 5 and 13, which won't give me any pairs. So I'm going to go ahead and I'm going to start off by rationalizing. So I'm going to multiply that square root of 65 to the numerator and denominator. Okay, so once I do that, I'm going to get that 5 root, and we've got that 260 times 65 over, and then we'll get that 65 in the denominator. Okay, so to go ahead and moving into my step 3, we are going to simplify the radical. And so I'm going to rewrite this down below, and we're going to factor. So we have that 260 times 65. All right, so some factors of that 260. Well, it's ending in a 0, so I'm going to start off with just dividing it by 10, and then we'll get 26. Okay, so then for my 10 here, I can factor it into 5 times 2. That 26 can be factored into 2 times 13. And then my 65 here can be factored into 5 times 13. Well, this helped me out quite a bit because I'll notice here that I have a pair of 2s. I have a pair of 5s. And I have a pair of 13s. So I can go ahead and I can pull them out. So we have 5 already out there times another 5 times 2 times 13. Okay, so 5 times 5 is going to give me 25. Times 2 will give me 50. And then when I multiply that by the 13, I'm going to be left with 650. All right, so I'm going to come back over here and I'm going to rewrite this as we'll have that 650 over 65, which 650 divided by 65 is just going to give me 10. All right, so let's move on to number 7. All right, so looking at question number 7 here, we have the square root of 96 divided by the square root of 54. Okay, so I'm going to go ahead and I'm going to show you another way of how you can work this out. Okay, so here we have that square root of 96 in the numerator. Well, some factors of that are going to be, we've got the square root of 6 times the square root of 16. Then I can look in my denominator and see that that square root of 54 has factors of that same 6. Okay, so that'll be helpful. And then 9. Okay, so the reason why I'm showing you this way is just because if you see that that square root, has a common factor, what you can do is write it out like this, and then these two will cancel out, and then you just have the square root of 16 divided by the square root of 9. Well, we know that the square root of 16 is 4, and the square root of 9 is 3. And that right there is my answer for number 7. All right, so real quick, I want to clarify this method that I just showed you here. This was just, another way of doing it. But I want to just clarify, it does not guarantee that you do not have to rationalize. It won't guarantee that your answer won't have radicals in it, anything like that. It just worked out for this specific problem that, we didn't have any radicals left over. All right, so let's move on to number 8. All right, so for number 8, we are going to start off by, once again, you can simplify the radical in the denominator since it does simplify. But for those of you that want to skip over that step and go straight into the rationalizing, you can. So I can multiply here that square root of 45 to the numerator and to the denominator. Okay, to clarify, you can also multiply by that 11, that coefficient there, with that root 45, but it just keeps your number slightly smaller if you avoid doing that and just focus on canceling out the radical. All right, so now that I've done that, I'm going to go ahead and I'm going to multiply. So we have 37 square root of 45 over the 11 times the square root of 45 times square root of 45 will just become a 45. Okay, then I'm going to come down here and do some scratch work. So that 37 square root of 45 can be simplified into, so here we can factor that 45 into 9 times 5. And then that 9 is a perfect square, so we can factor into 3 times 3. So I have a pair of 3's that I can pull out. And so I'm going to have 3 times that 37 that's already out front, square root of 5, because that's what's left over. So 3 times that 37 is going to give me 111 square root of that 5. Okay, so going back up here, I'm going to replace my numerator with that. We got that 111 divided by 5 over, and here I'm going to make my life a little bit easier. I'm going to leave it as that 11 times 45 and just simplify it this way. Okay, so looking at it, here we have that 111. I can divide that by 3. And so when I divide that by 3, I'll have that 37. And then I'm going to look in the denominator, and I need to divide one of these numbers by 3 as well. Well, the 11 won't divide, but that 45 does divide by 3, and that's going to give me 15. Okay, so then I just need to multiply, what I have left back together because I can't simplify anything else. So here I'm going to do a little bit of scratch work. Okay, and I'm going to multiply that 11 times 15 just because I don't know what that is off the top of my head. So 5 times 1 gives me 5. 5 times 1, get another 5. Bring down a 0. We got that 1 times 1 gives me 1, and 1 times 1 will give me another 1. So adding these two together, I'll get 165. So going right back over here for my final step here, I'm going to have that 37 square root of 5 over, and then we'll get that 165 in my denominator. And there you have your answer for number 8. All right, let's move on to the last one for this front side of these notes. We have for number 9, we have that square root of 75 divided by the square root of 10. Okay, so we can multiply by that square root of 10 to the numerator and denominator. Okay, so then I'm going to get the square root of 75 times 10 over, and then in my denominator, we'll just get that 10. Okay, once again, I'm going to come down here and I'm going to do a little bit of scratch work off to the side. So that square root of 75 times 10. So some factors we have is going to be 3 and 25. Then I can factor that 25 into 5 times 5, which will be very helpful. I'm going to highlight that pair. And then I have that 10 can be factored into 2 times 5. So I'm going to have a pair of 5s, but then I have left over 3, 2, and a 5. And so I'm going to get 5, and then we'll have that square root of 3 times 2, which gives you 6, times 5, which will give me 30. So 5 square root of 30. I'm going to come back over here. I'm going to replace that with 5 square root of 30 over 10. Okay, and lastly, I know that my radical is fully simplified. I'm going to check that fraction, that 5/10 can be simplified to, we've got 1/2. And so we'll write the square root of 30 over 2. All right, so now let's go ahead and look at the backside where we are going to go over adding and subtracting radicals. All right, some steps that we can do here are going to be step 1, very important. Make sure you are simplifying all of your radicals. Step 2 is identify radicals with the same radicand. Okay, note only these can be combined. So, think about like with your variables, we can't add 3x plus 2y. They're not the same. Here, you can't add any radicals or subtract any radicals that don't have the same radicand, the number under the radical. And then step 3, for your common radicals, you can add or subtract the coefficients and keep the same common radical. All right, let's look at this first one here. So I'm going to just go through and I'm going to simplify. Okay, so here, some factors of that 28 are 4 and 7. Then I can factor that into 2 times 2. So that's going to give me a pair that I'll pull out. And we'll have that -2 with the leftover 7 underneath the radical. Then we've got that -8. Okay, to clarify, it's not under a radical, so please do not factor it. And then lastly, let's look at that square root of 112. So here we can factor, start small if you need to, but it's an even number, so we can divide by 2 and 56. And then I can factor that 56 into, we've got our 8 times 7. And then my 8 can be factored into 4 times 2. And then 2 times 2. So we'll have our pair of 2's here. Pair of 2's over here with that leftover 7. Just because I did forget to cross off that 4, but it was used to clarify. All right, so I'm going to pull out, we've got a pair of 2's times another pair of 2's with that leftover 7, kind of running into it. But then we can go through and simplify. So we're going to have that -2 root 7 minus 8. And then we'll have that 2 times 2 gives me a 4 root 7. Now, noticing here that we do have that same radical, that square root of 7 here and here, which means you can combine the coefficients. So -2 minus 4 will give me -6 square root 7, and then that minus 8. And that would be your answer for number 10. All right, so now let's look at number 11. Okay, so in number 11 here, we can simplify that square root of 54. We can factor it into 9 times 6. And that 9 can be factored into 3 times 3. And then my 6 can be factored into 2 times 3. Okay, so I already went ahead and highlighted my pairs, so I'm going to pull them out. I've got that -3. It's already negative in front. And then we'll multiply that 2 and 3 back together to get that 6. And then we have that plus 7 root 6. Okay, so this will become -3 root 6 plus 7 root 6, since we do have the same radicals. Here we got that square root of 6, square root of 6. We got -3 plus 7 is just going to give me a positive 4 root 6 for my answer. All right, moving into number 12. All right, so I've got 4 square root of 63 plus 6 root 28. So I can factor that 63 into 9 times 7. And then that 9 can be factored into 3 times 3. Okay, so I can rewrite this as that 4 times my pair of 3's I'm going to pull out. Square root of 7, because that was the only number left over. Then I'm going to come over here and simplify this radical. So I've got 4 and 7 are factors of that 28. Then I can factor that 4 into 2 times 2. And we'll have that same leftover 7. So coming down here, we'll add 6 times the 2 I'll pull out with my leftover 7. So we've got 4 times 3 is going to give me 12 square root of 7, plus that 6 times 2 gives me 12 square root of 7. And so we can combine my coefficients. 12 plus 12 is just going to give me 24 square root 7. All right, now let's move into number 13. Okay, so for problem 13 here, we are going to FOIL. Okay, we're going to multiply. We'll have here that root 11 times the square root of 11. Then we'll have that root 11 times the negative square root 17. So positive times negative gives me a negative 11 times 17. Then we'll get that same thing here, but this time we got a positive times a positive. So plus the 11 times 17. And then we've got that root 17 times negative root 17. So we'll get another negative. And then we got that 17 times 17. So here we have our pairs here and here. So we're going to pull those out. But if you look in this middle section here, I don't even have to worry about multiplying those together, that 11 times 17, because I'll notice that I have the same thing, but one is positive, one is negative. They will just cancel each other out. And so I'm going to have that 11 minus 17, which will give me negative 6. Okay. Moving on to number 14, we have negative square root of 96 divided by 3 plus the square root of 24 divided by 2 plus the square root of 54 divided by 6. Okay, so what I'm going to do first here is you need to keep in mind, in order to add fractions together, you need to have the same denominator. Okay, so I notice here that 6, okay, I've got 3, 2, and 6. So if I can make all of my denominators 6, then I'll be able to add the numerators together to simplify. Okay, so in order to make that happen, I'm going to take my first fraction, that negative square root of 96 over 3. I'm going to multiply that by a 2 over 2. Then I'm going to add the square root of 24 over 2. And I need to multiply this so that I can get that 6 in my denominator by a 3 over 3. And then we'll have that plus the square root of 54 over 6, which this one I don't need to worry about because we have that denominator of 6 already. All right, so now that I've done that, I'm going to go through and I'm going to simplify a little bit. So I'll get negative 2 square root of 96 over 6. Plus we'll have here that 3 root 24 over 6. Plus the square root of 54 over 6. All right, so now since all of my fractions have the same denominator, I can go ahead and I can add the numerators. So I'm going to just write this as one fraction with all of these being added, but I will need to then take a second after this and actually simplify all of these radicals to see what actually can be combined together. Okay, so it's going to look like this. So let's do a little bit of scratch work off to the side over here. Okay, so I'm going to take that, we've got negative 2 root 96, and I'm going to simplify. I'm going to do the same with that 3 root 24, and then my root 54. Okay, so some factors we can have here are going to be 8 and 12. And we got 2 and 4. And that 12 can be 4 and 3, which will help me out because that will give me a pair. So I'm going to pull out that 4 and multiply it by the 2. It's already out front. We'll multiply that 3 and 2 back together. And this will give me negative 8 root 6. Moving into the middle term here, we're going to factor into, we got 6 and 4. And that 4 can be factored into 2 times 2. Okay, based off what we just saw in the previous one, I know that my 6 being factored won't help me here because I already have a pair of 2s, which means I'll just have that 6 underneath, and 3 times 2 won't give me any more pairs. So I'm going to pull out that 2 and multiply it to the 3, and then times my 6 that's left over, so 6 root 6. And then one more, we've got that 54 can be factored into 9 times 6, and then that 9 is going to be 3 and 3. So once again, I'm not bothering with my 6 here because I know from the first one that that won't help me. But I do have a pair of 3s I can pull out with that root 6 left over. So going back over here, I've got now negative 8 root 6 plus 6 root 6 plus, and I forgot it, we have 3 root 6 all over 6. So let's look at our coefficients and combine them since we all have the same radicand. -8 plus 6 will give you -2, plus the 3 will give me a +1. And so my final answer is root 6 divided by 6. All right, our final problem, number 15. Okay, so for 15 here, I'm going to take these fractions under the radical and I'm going to separate them into the square root of 3 divided by the square root of 4 plus the square root of 1 divided by the square root of 3. All right, so what I notice here is that I have two perfect squares. I have the square root of 4, which is just 2. So I'll have the square root of 3 divided by 2. Plus, we'll have that square root of 1, which is just 1 over the square root of 3. All right, so, there's a few things you can do here to kind of work this out. I'm going to go ahead and start off by just rationalizing this second fraction here. I'm going to multiply it by the square root of 3 to the numerator and denominator. Okay, so when I do that, I'm going to end up with my first fraction being the same, that square root of 3 over 2 plus, and now we're going to have the square root of 3 in my numerator, and the square root of 3 times the square root of 3 will give me 3 in my denominator. So like the previous problem, we need these two fractions to have the same denominator. And so what I'm going to do is I'm going to multiply this first fraction by 3 over 3. And the second fraction I'm going to multiply by 2 over 2. And this is going to give me 3 square root of 3 over 6 plus, and then we'll have 2 square root of 3 over 6. All right, so the key thing is that when you are adding fractions, they have to have the same denominator. But when you actually go and add them, you are only adding the numerator. Okay, the denominator being the same allows you to add the numerators. And so here we'll have that square root of 3 in common for both of these. And so I can have that 3 plus 2 will give me 5 square root of 3. And then we will have just that 6 in my denominator. So my final answer here is 5 root 3 divided by 6.